Due to the blasting environment being very dusty and polluted with air contaminants, all abrasive blasters use a supplied air respirator. This means we need to make careful note of their quality of breathing air. And we started our Performance 3 recommendations focused on choosing the right air compressor. Our focal point now turns to a downstream safety concern caused by that very compressor. 98% of all industrial blasters use supplied air from the compressed air to supply the actual oxygen keeping them alive during their workday. Carbon monoxide is a naturally occurring odorless, deadly gas. If the carbon monoxide is drawn back into the air intake, which is an unavoidable reality, that CO is now part of the breathing air traveling downstream into the blaster's respirator helmet. The three most common sources of carbon monoxide are 1. Equipment like trucks or forklifts that are idling near the air intake of the compressor. 2. The compressor being staged downwind from other equipment or in a shallow dip in the land where the heavy air will hang. And 3rd, older compressors naturally overheat, producing carbon monoxide, which ends up in the air, making its way into the blaster's lungs. All countries around the world have standards for the quality of supplied breathing air. For example, in the United States, OSHA's standard is 1910.134, Section I, subsection 7. Part of OSHA standards require filtering the air for oils, odors, particulates, and part is for monitoring and alarming for the odorless, tasteless, but deadly carbon monoxide. Using a high-quality breathing air filter like an RPB Radix will pass all the air through a 6-stage filter that removes from your compressed airstream moisture, odor, and particulates down to 0.5 microns. The Radix uses an easy-to-replace filter cartridge that lasts up to 3 months or 400 working hours. To maintain contaminant-free air, it's important these filters are replaced regularly. Carbon monoxide alarms are a vital part of a blasting system, and these systems will continually monitor the breathing air for carbon monoxide and trigger an alarm when the level in the air exceeds 10 parts per million. Too often, people don't keep up the calibrations of their alarms, which means their blasters are no longer protected from the dangerous gas.
So have you ever been on a job site where you've been asked if you have grade D breathing air? What is grade D breathing air? If you look at the standard, it has a maximum level of carbon monoxide, has a minimum level of oxygen, has a criteria for percentage of hydrocarbons, which is oils, and it requires you to filter it, monitor it, and so on. A lot of facilities will say, I want you to use a free air pump. Problem with just using a free air pump is that it's still prone to pulling in the surrounding atmospheric air to create that breathing air, which means that if a combustion engine, such as a delivery truck or another compressor, is nearby, it's still at risk of pulling that contaminated air into the free air pump and sending it on down to the blaster. So something you always need to look at when you're setting up your job site, creating a barrier around where your breathing air source is, your compressed air source is for your breathing air, to make sure that no combustion engine can come close. We still recommend testing your breathing air, even if you have a free air pump, to certify that it is free of carbon monoxide and has the right levels of oxygen. Because you could be in a area where it's starved of oxygen, and how do you really know that you have the 19.5% to 21% of oxygen that the standard requires? You don't know without actually testing it.
Reminder: constantly monitoring and purifying your breathing air to protect your blaster is a critical part of your overall blasting system.